Let's move on to the third problem. The batch dryer treats 500 kg of wet solids. So the feed is given containing 60% moisture. During drying, 80% of the water in the feed is evaporated. Find mass of water evaporated, final product mass, and final moisture content. So to solve a drying problem, as usual, we draw the schematic. Now we'll fill the given data. So the feed is 500 kg. So we have filled the 500 kg here. Then the percentage of moisture is given, which is 60%. So I have replaced the water percentage as 60. So remaining would be solid. So it comes to be 40%. Coming to water evaporated stream, we know that the solid percentage in the water evaporated is 0 and the water percentage is 100. But the amount of water evaporated is given indirectly in the question. Coming to the stream M3, we are not given any details. So we are assuming as x and 1 minus x as usual we did for the problem 2. So the solid percentage would be x and water percentage would be 1 minus x. Now let's go to the three main equations. One is overall mass balance equation, then water balance equation, then solid balance equation. In overall balance equation, one stream is entering and two streams are coming out. So the input is M1 and the right hand side is output. There are two streams, so M2 plus M3. So coming to the water balance, we're going to multiply each stream by its respective water percentage. So M1 is multiplied by the water percentage in the feed stream. M2 will be multiplied by the water percentage in the water evaporated M2 stream, and M3 will be similarly multiplied by the respective water percentage. We do the same for solid mass balance also. In these three equations, now we replace the given data value here. So in this M1 is equal to M2 plus M3, M1 value only we know. So I am replacing M1 by 500 because it is given in the question, and the M2 and M3 we are keeping as it is. Moving on to water balance. So the percentage of water in the M1 stream is 60%. So 60% into M1, M2 value we don't know, but the water percentage is 100%. I am multiplying M2 with 100%. Plus M3 stream, the water percentage is unknown, but we name it as 1 minus x. So we are giving here 1 minus x into M3. Coming to solid mass balance, we are multiplying the stream 1 by solid percentage in the stream 1, which is 40%. So 40% into M1 is equal to the solid percentage in M2 stream is 0. So 0% into M2 plus x times M3 because the solid percentage in the M3 stream is x. Let's solve this three equation now. Now we calculate the interesting part in the problem, that is calculating the amount of water vapor in this drying process. The question says during drying 80% of the original water in the feed is evaporated. First of all, we have to identify how much water were in the feed. The question says 60% moisture in the feed. So the feed is 500 kg. Out of 500 kg of feed, 60% is moisture. So when I multiply 60% with the feed mass, which comes to be 0.6 into M1, which is equal to 300 kg. So the water in the feed is 300 kg. Now let's read the question again. During drying, 80% of original water in the feed is evaporated. So the water in the feed is 300 kg. Now in this 300 kg, 80% of water is evaporated. So M2 would be 80% of water in the feed. 80% is 0.8 into water in the feed is 300 kg, which is equal to 240 kg. We have calculated M2 value now. Now we can move on to M3 value. In this equation, 500 is equal to M2 plus M3. Now M2 we have calculated as 240 kg. So M3 would be 500 minus M2 value, which is equal to 500 minus 240, which is equal to 260 kg. Now we have calculated M2 as well as M3. Coming to the water balance equation, so it is 0.6 into M1, which is equal to 100% is 1 into M2 plus 1 minus x times M3. M1 value we know, M2 value we know, M3 value also we know now. So we can find the unknown value x in this equation by rearranging this equation. I am substituting all the values here. I am rearranging for 1 minus x, so which comes to be 0.23. To find the x, I am rearranging this value, which comes to be 0.77. So the solid percentage is 77% and the water percentage is 23% in the final product stream. Problem 4. A wet feed of 600 kg contains 55% moisture. The dried product must contain 8% moisture. Find percentage of water removed from the feed and mass of water evaporated. The first step in solving the mass balance problem in dryer is drawing the schematic. So in dryer, there will be one stream entering, that is feed, and two streams will be coming out. One is water evaporated stream and is a dried product stream. In the water evaporated stream, that is the M2, so no solid will be evaporated. Only water will evaporate and it move away. The solid will remain same. That's why we can say in the stream M2, solid percentage is 0 and water percentage 100%. Now from the question, whatever is given, the feed value is given as 600 kg. Hence I have filled M1 as 600 here, and the moisture percentage in the feed is 55%. Hence I am writing water percentage as 55. So the remaining must be solid percentage. Then the dried product must contain 8% moisture. So they're talking about this dried product. So this must contain 8%. So the remaining must be solid, that is 92%. Now we got the composition of solid and water percentage in all the stream. Now let's write the mass balance equations. The first one is overall mass balance. There is one stream is entering, so M1 in the left hand side. In the right hand side, output stream. So there are two output streams, M2 and M3. So M1 is equal to M2 plus M3. In water balance equation, we have to multiply the respective water percentage for each stream. For solid, we will be multiplying with solid percentage for each stream. Now let's replace the known value in these equations. Now in this overall mass balance equation, we know M1 only. M2 and M3 is unknown. So we are keeping the equation as it is. M2 plus M3 is equal to 600. Moving to the water balance equation, the water percentage in the M1 stream is 55%. Hence we are multiplying M1 with 55%. The M2 stream, the water percentage is 100. So we are multiplying with 100%. The M3 stream, the water percentage is 8. Hence we are multiplying with 8%. Similarly, we do for solid balance. 45% of solid is present in the feed. Hence we are multiplying the M1 stream by 45%. In M2 stream, the solid percentage is 0. In M3 stream, the solid percentage is 92. Hence we are multiplying with 92. In this question, we are asked to calculate percentage of water removed from the feed. So from the feed, how much water is removed? Because of that, we need to know how much water is there in the feed. So water in the feed can be calculated by multiplying the percentage of water in the feed with mass of the feed. The mass of the feed is 600 kg and the respective moisture in the feed is 55%. So 55% of 600 kg will give me amount of water in the feed. In this case, it's calculated to be 330 kg. So 330 kg of water in the feed. Now let's go back to solving this equation. M2 plus M3 is equal to 600. We don't know M2 and M3 value. So we keep the equation as it is. Moving to water balance equation, 55% can be written as 0.55. So 0.55 times M1, which is equal to 1 times M2 plus 0.08 times M3. Moving to solid balance equation, so 0.45 times M1, which is equal to 0 times M2 because solid percentage in M2 stream is 0 plus 0.92 times M3. If you see this equation, here M2 and M3, there are two unknowns. In this case, M1 is known in the question. M2 and M3, there are two unknowns again. Here if you come, M2 is gone. We are left out with one variable, that is M1 is already known, M3 alone is unknown. By solving this, we can calculate the mass of the product stream. That is M3 is equal to 293.5 kg. Since we calculated the M3 value, we can use this overall mass balance equation to calculate the M2 stream also. So I can calculate M2 by 600 minus 293.5, which gives me 306.5 kg. Now I have calculated M1 mass, the mass of water evaporated, and the mass of the dried product. So we have calculated the mass of water evaporated here, but now we have to calculate the percentage of water removed from the feed. So the water removed from the feed is 306.5 kg. Water in the feed is 330 kg. Hence, to calculate the percentage of water removed from the feed is water evaporated divided by water in the feed. Water evaporated is M2. So water in the feed is we calculated. It comes to be 306.5 divided by 330 kg into 100, which is 92.9%. So the water in the feed is 330 kg. M2 we calculated as 306.5 kg. So the ratio into 100 will give me the percentage of water removed from the feed.